So let's start with 12D. Question number 1. A, y equal 2x square minus 6x plus 3. Then dy over dx, answer for this one is 2 times, this is going to be t, 4x minus 6. So how it comes? So this 2 you leave it, it's a constant. Then this one become 2x 2 minus 1. Then 6, leave it, so this is 1 x 1 minus 1 plus this is 0, constant differentiation 0. So this is become 4, this is x1 minus this is going to be 6 x0 plus 0. So 4x minus 6x. Sorry, 4x minus 6x0 is 1. Part B, y equal half x square plus 12x. Then dy over dx is half 2 times x. 2 minus 1 is 1. And this is 12. X differentiation become 1. When you differentiate x, it become 1. So the final answer is dy by dx is 2 cancel out, x plus 12. If you are not sure, so you can work like this: d over dx half 2 times x 2 minus 1 nx n minus 1 plus 12 times this is 1. So 1 x 1 minus 1. So this is cancel out. This is x plus 2 times 12. x1 minus 1 is x0. x0 is 1. Y equal 4x square minus 6. So dy by dx is 4 times 2x1 minus 0. Constant differentiation 0. So the answer is 4 times 2, 8x. And D, y equal 8x square plus 7x plus 12. So dy over dx is 8. I will leave aside. So this is 2x1 and this is 7 times 1. X differentiation become 1 and this is become constant. So dy over dx is 16x plus 7. Why x become 1? Because x1 differentiation is 1 x1 minus 1. So 1 x0. 1 x0 is 1. 1 times 1 is 1. Why 12 is 0? So 12 is 0 because this is x2, x1, this is x0. So x0 differentiation, when you differentiate 0 times x, 0 minus 1. When you multiply anything 0, the answer is 0. So this is E. 5 plus 4x minus 5x square. So y equal. Now dy over dx. When you differentiation plus 5, answer is 0. When you differentiation plus 4x, answer is 4. So And when you differentiate 5, okay, 5x square, this is minus 5x square, minus 5 times 2 times x. So minus 5 times 2 times x 1. So this is 4 minus 10x. So you can adjust this one if you want the way you like. 5x square plus 4x plus 5. Always this 5 belongs to left hand symbol. This 4x belongs to not minus, always left hand one. This 5x square belongs to left hand one, minus. So you can rearrange like this. If you draw this one in a paper and you can cut and you can arrange anyway. So plus 5 plus 4x, right, minus 5x square, or this direction plus 5. If you 4x plus 4x minus 5x square. Right now it's still the same. This is minus 5 to x1 plus 4 plus 0. So minus 10x plus 4. This is plus 4 minus 10x. Both same. So plus 4 and minus 10x. Only plus 4 term there, minus 10x term there. Here also minus 10x term and plus 4. Part 2. That's a equation. So this is y equal 3x square. I need to find in x equal to the gradient. What is the gradient mean? Tangent line. When you find gradient of the curve at this point mean that is the gradient of the tangent. So first of all we will find gradient of any point. So this is y equal 3x square, then dy over dx is, this is going to be 6x, 3 times 2x1. So this is 6x. Now at which point x equal to dy dx, when x equal to, it means you want to substitute what is the command given, insert x equal to, so 6 multiply by what is the x value, 2. Answer is 12. The gradient is 12. So the tangent gradient is dy by dx is 12. If you are not happy to write dy by dx, you can write gradient. Or if it is y equal mx plus c line, because this is a y equal mx plus c, usually we write the equation of a line. You can tell this is m as well. So this point is 212. So only here there is no y term here. Only x term is left. So we don't only need x equal 2 from here. We don't need 12. So answer is 12. Actually, you can remember that we work with this kind of thing with the first principle. 2 and 12 one point. The other point is 2 plus h. We will take a point here, 2 plus h, and then 3 times 2 plus h square. Then we write, and this is one coordinate, this is the other coordinate. So y1 minus, this is y1 y2. So 3 times 2 plus h. So I substitute 2 plus h square minus 12 and 2 plus h minus 2. If you are confusing, you can write this is 2 and this is 3 2 square. 3 times 2 square. 12 mean 3 times 2 square because y equal 3x square. Then when x equal 2, y equal 3 times 2 square. So if you confuse with 12, 3, 2 square. So this is 1 point when x equal 2. Now this is when x equal 2 plus h. And you get the gradient. So, and then you take the limit. So this is going to be 3, 2 plus h square minus 12 over h. So this is 3 times 4, 4h plus h square minus 12 over h. So this is going to be 3 times 12. This is 12h, h square minus 12 over h. So 12 to this 12 cancel out, 12h over h plus h square over h. So I forgot to write the limit. Limit h goes to 0, h goes to 0, h goes to 0. Then answer is this is equal to L-H. So when h goes to 0, answer is 12. Now this is from the first principle. Instead of that, now we have a short method. The next one is B, y equal x square plus 4x at 1, 5. Now dy by dx is 2x plus 4. Then dy over dx when x value is what? 1. So then 2 times 1 plus 4, which is 2 plus 4 is 6. So when you have the curve, say like this, this curve is y equal x square plus 4x. This is y-axis, x-axis. So you want to find the gradient x equal 1. So this is the tangent line. So when you find the gradient of this point mean that is equal to the tangent line. So tangent line gradient. So dy by dx is 6. If you draw properly and take y1 over x1, or this is AB, A divided by B, you should get a approximate answer to 6. Dy over dx is, this is going to be 4x and this is minus 1. Then we need at x equal to, so dy by dx when x equal to 4 times 2 minus 1. 8 minus 1 is 7. So the gradient of tangent line is at x equal to is 7. Question D. dy over dx is half I keep separately 3x square 3 minus 1 2 plus 3 over 2. So dy over dx is 3 over 2x square 3 over 2. Now I don't need y because there are no y terms here. Only I need x. So dy over dx at x equal 1. So then 3 over 2, 1 square, x is 1, plus 3 over 2. It means 3 over 2 plus 3 over 2, which is 6 over 2 is 3. I think uh, instead of 3 I put 2, I put 3 here. I have to rework this one with 2. So this is going to be dy over dx is half, we'll keep the constant separately, and then 2x plus 3 over 2, 2 to 2 cancel out. Dy over dx is x over 3 over 2. Now I need dy over dx equal x equal 1. So this is 1 over 3 over 2. This is 5 over 2. Now dy over dx is, this is 0 and minus 2x this is. Now is, so dy over dx is minus 2x. So at x equal 1, so dy over dx at x equal 1 minus 2 times 1 minus 2. So gradient is minus 2. Part F, dy over dx is constant differentiation 0. So this is minus 2, and then we'll leave it separately, and then 2x. 2 minus 1 is 1. So final answer is minus 4x. So dy over dx at when x equal minus 1, answer is minus 4 times minus x. Anyway, in mathematics, if you substitute minus number, always make sure you write in a bracket for safe side, right? So this is going to be 4 times 1, 1, that is positive 4. Assume what is the curve is given, x square plus 5x minus 4. Assume you have a curve like this. Now find the y coordinate and the value of the gradient at point P. The P coordinate is x equal 1. Okay, I'll take this is x equal 1. I'm not sure it is here, I'll drag to here. So this is x equal 1. So I have the coordinate 1. I need y coordinate. How I'm going to find the y coordinate? So we can substitute this one. So then for y equal, when x equal 1, y equal 1 square plus 5 times 1 minus 4. So this is 5, 6, 6 minus 4, 2. What is the y value is now? 2. Okay. This is GCSE sum. This is not A-level mathematics. Now let's find the gradient of this point. What is the meaning of the gradient? It means we are really find the tangent line gradient. So gradient of this point is equal to tangent line. Gradient of the tangent line. Okay, now we will differentiate. Dy over dx is 2x plus 5 plus 0 minus 0. So dy over dx is 2x plus 5. Now I need the gradient of this point, not y value. Y value we found out, x equal 1. Now dy over dx when x equal 1, 2 times 1 plus 5. So this is 7. So gradient of this point, m is 7 in other way, over dy by dx, or tan theta. M equal dy by dx equal tan theta, or from the letters you can write wordings, gradient, gradient. Question number 4. Okay, like this. I'll take like this without anything. So you have a curve y equal x square plus 5x minus 4. Now they want to find gradient 3. Now it has different gradients. Right? In one place somewhere in this curve is gradient dy over dx is 3 at x equal, let's say, a point. So if you take this point, a point, b point, x equal 1 point, x equal minus 2 point, likewise. So we don't know which point. We know in one point like this, for one x value, it will give 3. Now we'll work out first of all dy by dx. Okay, dy over dx is 2x plus 5. So let's take that particular x value is a. Let's take that x value is a, then dy over dx x equal a. This is 2a plus 5. Right? Now this value is equal to what? 2a plus 5 value equal to 3. So then 2a equal 3 minus 5. So 2a equal minus 2, a equal minus 1. So a is not in this area, a is in minus area. Right? There are so many gradients for this curve, for a lot of points, but if you look at x equal minus 1, what is the gradient of this line, a tangent line? 3. So dy over dx is 3. In the previous, we gave the point, they gave the point, we need to find dy by dx. Now they gave dy by dx and we need to find point. Just to recap now, the curve has different gradients on this curve, on this curve. So if I explain properly, like if you take a point in this curve, and if you take another point of this curve, it has two different gradients. Each and every point has different gradients. But only one particular point have x equal 3. sorry, the dy by dx, gradient is 3. What is that point? So the way we find this point, we want to find dy by dx, and then we want to make equal to 3, and then you will get minus 2x equal minus 1. Sorry. So instead of working with x, it is really nice to work with the right idea, because x is any point. So instead of that, we can write in terms of a special point. That point we need. Let's take that particular x value is a. So then simply I sub, instead of 2x plus 2a plus 5. But this is after finding the gradient. Actually, in this sum, number 4, we need to find the coordinate. So we found out x equal minus 1. When x equal minus 1, we need to find what is the y value. So x equal minus 1, y equal x square plus 5x minus 4, then minus 1x square when x equal minus 1, times 5 times minus 1 with bracket. So minus 1 square become plus 1, minus 5 minus 4. This is going to be minus 8. So coordinate is minus 1 minus 8. Right? For this curve, when x equal minus 1, x equal okay, in this coordinate, in this point, the gradient is minus 3. In this sum, number 5, find the gradient of the curve y equal x square plus 5, 10. Okay, find the gradient of the curve. Okay, we'll find gradient of any curve. X square minus 5x plus 10. So then dy by dx is 2x minus 5. This is any point x. Now they're talking about at the point A and B. They don't want any point. They want 2 points. A and B. Where this A and B lies, we need to find the coordinates. So when this curve A and B, so what is y equal 4 line? It means y value always equal 4. When you walk, y value is not changing. It always 4. So then those are the 2 points. I don't know which side of this one, but okay, I will leave as it is. So then we know y coordinate is 4. Then y coordinate is 4. What is x? For that, we need, this is A and this is B. We want to find the gradient of this point. So this is the gradient, and this is this gradient. We need to find the gradient of those 2 points. To know that, I need to know what x values. So we'll then I'll come to GCSE now, year 10. So we know that y equal x square minus 5x plus 10, and then y equal 4. We'll solve this one. And okay, x square minus 5x plus 10, instead of y I will put 4. So x square minus 5x plus 10 minus 4 equals 0. X square minus 5x plus 6 equals 0. What I am doing now, I am finding the intersection point, quadratic and that, and this y equal 4 line. So this is here 10 level knowledge, not the 11 advanced level. So this is going to be x minus 2, x minus 3. equal 0, x equal 2 and x equal 3. So this point is x value is 2. So this is 2, 4 and this is 3, 4. Now I found out the x values. Now dy by dx at x equal 2. So we can write symbolically like this. X equal to, what is dy by dx? 2x we found out. 2 times 2 and minus 5. So 2 times 2 minus 5. This is 4 minus 5 minus 1. So now dy by dx at 3 when x equal 3. So then here. So this is 2 times x value is 3 and minus 5. 6 minus 5 is 1. So this gradient is minus 1. So this kind of 1. So okay. So I'm not going to write. So this gradient is minus 1. This is, and this is y equal m. Let's say this m is 1. This is m is minus 1. If this point is go through, assume 4, 5 point, or it is going through 3, 4 point, you can find the, now y equal mx plus c. So you can find the equation of line. Same way you can find the equation of this line. Sometimes they will ask find the intersection point. Then you have to solve those two lines to get the intersection point. So that is how the in advance it will get advanced. So number 6, find the gradient of the curve. Okay, we'll find the gradient of any curve first. Y equal 2x square. Then dy over dx is 4x. So this is any point on the curve. Here, 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 here. But they don't want any point. Any point? No. They want C and D. Where? Where the C and D lies? C and D curve meet. So they have given curve meet the line. This y equal 2x square meet y equal x plus 3 line. This is y equal x plus 3 line. This is the curve y equal 2x square. Now this is C and D intersection point they are talking about. Now we want to find this intersection point. If you have two equation, how do you find intersection point? By solving simultaneously. So I can write this is 2x square equal x plus 3. So 2x square minus x minus 3 equal 0. So when you factorize, this is 2x minus 3, x plus 1 equals 0. Then 2x equals 0 and x equal minus 1, x equal 3 over 2 or x equal minus 1. Now x equal 3 over 2 will find the y coordinate as well. So x equal 3 over 2, y equal, you can find from any equation, but this is the easy one. X means 3 over 2 plus 3. So this is going to be 9 over 2. Or you can find from here as well, from this one. Y equal 2 times 3 over 2 square. So anything wrong? So this is 2, 9 over 4. So this is cancel out and 9 over 2. Use anything but easy one. So I found one point is 3, 2 and 9 over 2. when x equal -1, y equal -1 plus 3, it is 2. So -1, 2. So C is -1, 2, and D is 1.5. 3.2 mean 1.5. This is 4.5. 4.5. Now we have the gradient in our hand. Now I want to find the gradient for this point. When you find gradient for this point, what is the meaning of that? Can you remember? P and Q, I bring the Q down, and finally it has become tangent. So likewise, we are finding the gradient of the tangent for this point. So that is the meaning of that. So we'll find it now at point 1. So dy over dx when x equal -1. So this is going to be 4 times -1 minus 4. Then at here dy over dx when x equal 1.5. So 4 times, this is dy by dx gradient, 4 times 1.5. This is going to be 4 times 9, 3 over 2. This is 6. This is for gradient in any point. So we only need C and D. To find C and D, we should know what is x and what are the x values. So we solve these two equations and we got x values, and now we can find. So fx equal number 7, x square minus 2x minus 8. So f dash x also dy by dx. If you take this is y, everything same. This is 2x minus 2. Now this is also function of x. This is also function of x. So we'll sketch fx equal x square minus 2x minus 8. Now we'll discuss, I think you can remember now how to sketch. So a greater than 0, greater than 1, hence fx has a minimum. Now we'll find which the curve cut y-axis. It means x equals 0. When x equals 0 at y-axis, x value is 0. F0, I will take y, or f0 is 0 square minus 2 times 0 minus 8. So that is minus 8. So it is going 0 minus 8 point. Now I want to find where this curve cut x-axis here. In here we know that y is 0. Then we'll pay y or fx is 0. So y or fx is 0 here. So now x square minus 2x minus 8 equals 0. Now we have to factorize this one. X minus 4, x plus 2 equals 0. X equal 4 or x equal minus 2. So this is one point is minus 2 and other point is 4. 4, 0. What else we need? We need the minimum point. So we'll complete the square for that. X square minus 2x minus 8 equals 0. X minus 1 square minus 9 equals 0. So then actually y, I will take y. So x equal 1 is the symmetric line, and 1 minus is the minimum. So x equal 1, this is x equal 1, this is y equal minus 9, and it is going through 0 minus 8. So something like this. So this point is minus, we found out, minus 2, 0, this is 4, 0, this is x and this is y. And yes, this point is 1 minus 9. I think we are done now. This is 0 minus 8. Cut in y-axis. Right, that's fine. Now we want to sketch y equal f dash x. It means y equal f dash x means 2x minus 2. This is just a line. So when x equals 0, y equal minus 2. One point is 0 minus 2. When y equals 0, x is 1. So this is 1, 0. So one thing is it's going through 1, 0 in here. Because this is x equal 1 line. This is going to 1, 0 and 0 minus 2. Yeah, it's going like this. This is 0 minus 2 and this is 1, 0. This curve is like this. So now part C, explain why the x-coordinate of the turning point. So x-coordinate of the turning point of y equal fx is the same as the, so this coordinate same as the x-coordinate of the point where y equal f dash x crosses. So the question is, in here this curve go x value also 1, and this curve also this x value is 1. So they are asking why this is basically. Both have the same. Now, first of all, what is this is curve. What is this one? This is the gradient curve for this curve. So what is the we'll look at like this. This curve in here, do you think in this point there's a gradient? Yes. In this point gradient, yes. In this point gradient, yes. In this point, yes. In this point, yes. In this point, is there's a gradient? Yes. Is this point is a gradient? In the mini point, yeah, there is a gradient, but that gradient is 0. But Any other places gradient is there, but it is not 0. The gradient value is 0. Now this line tell about the gradient. So in here it has a gradient. In here it has a gradient. So for this value, right? If you take this x equal minus 2.5 or something, so the gradient of this point is this. The gradient of this point, if you want to find, just draw a perpendicular line to this one and extend. This is the one, right? So likewise, gradient of this point is this. Sorry, gradient of this point is this bit. This is the x value. So gradient of this point is this height. So gradient of this height here, no height, because this will this is the gradient curve. Assume this is animal. You are checking the temperature of these places. Okay, there is temperature. Yes, 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 and no temperature. So you can see that no temperature here. Likewise, this is gradient curve, and so if we want to find the gradient of this point, so then this is x value. So you want to extend. So this is the gradient curve. So this is height. So likewise, at this point, gradient no height, gradient is 0. So answer is at minimum point gradient is 0. Let me ask another question. I draw a curve like this. Now I ask you to find the gradient of this curve and draw that the gradient curve. So how do you do the gradient curve? So you'll take this point, assume this point. What is this one? X equal 5. Then you draw the gradient. So assume that this have a coordinate for this point 5, let's say 7. Then you want to gradient of this point, right? So you do a manual part. Then you find you measure this length and you measure this length, right? When you measure this length, say, and this is 3.5. Now when x equal 5, what is the gradient? 3.5. So this point on the curve, what if I draw a gradient on the same? When x equal 5, the gradient is 3.5. So this is the gradient point. So I can do a different one. When x equal 4, same thing, right? This is 4, 6 curve. I just assume this one, this y values. Otherwise you need to give the equation, right? And then you measure this height, and you found out when x equal 4, the difference, that value, division value is 2. So then you are measuring on the same place. 4, 6 is here, 4, 2 is somewhere here. To draw a line, it is enough 2 point. Now we have a 2 point, then we draw the line. And now this is the gradient curve. You know that in this point, gradient is 0. Is the gradient line go through this point? Yes. because this is the minimum point of the curve.